Hi, and welcome to week one of my 26 weeks of Leetcode contests challenge. So I'm going to be doing this on Saturdays, ideally Saturday mornings. And this week I can see that there's a bi-weekly contest that's starting in about 3-4 hours. But I'm not going to wait for that because that'll be later in the evening my time. So instead, I'm going to use Leetcode's virtual contest rewind feature and have a look at this Airwallex contest they had last week. For those of you who don't know, some of these contests get sponsored by companies, and yeah, you stand a chance to win prizes and I guess as well to get invited for interviews. So let's just start things off. Oh wait, is there anything else I should explain? When I'm done with this virtual contest, I won't actually get placed on the ranking board, but I will see where I would have gotten placed if I had taken place in the actual contest. So yeah, this is just a good way for me to practice towards actual contest. And the goal for this is sometime in the third quarter, towards the end of the third quarter, I should hopefully be ranking in like the top 10%. So that's like the first 100 rank out of typically 1,000. No, out of typically about 10,000 people who contest. Let's just see what let's just see how many people took part in this contest by going over to the last page. Okay, no, 857. So about 20 something thousand people took part. Um, yeah, there's a tool I made to help me figure out what rank I need to place in to be in the top 10. I don't know that I can do that easily um, with 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 Leetcode. It's not immediately obvious because first of all you need to find because first of all I typically would like to remove all these people who didn't even take part right in the contest and then kind of rank myself within those people that did take part. So that's one thing to note. And the other thing to note is, yeah, they're typically just 4 questions, and the later questions have the highest scores. Scores are typically standard 3, 4, 5, 6. The first two I've noticed are typically kind of like array type, non-complex data structure type questions. And the last two are typically like dynamic programming or graph search or linear programming type questions. These are the ones I really struggle with. And hopefully I will be much better at them by the time I'm done with these challenges. So those out of the way, I'm going to get cracking. Let's start with challenge one, problem one, largest number. So problem one is largest number after digit swaps by parity. It's an easy rated question, and typically with those I want to aim to spend about at most 10 minutes, 10 to 15 minutes. So hopefully that happens. Typically it doesn't. All right, what's the problem? We are given a positive integer num, and I may swap any two digits of num that have the same parity. By parity, we mean both odd digits or both even digits. Cool. So we may swap any two digits that have the same parity. And at the end of the day, I want to return the largest possible value of num after any number of swaps. So off the top of my head, tools that are coming to mind are how you can, if I effectively get the digits in a number by using the modulus operand in some sort of loop, as you progressively divide by a factor of 10, I believe it is. So that way we can create an array of all the digits in our number, and then we can play around with the digits, swapping them. Um, Another thing that comes to mind is when returning the largest possible value of num, do we not just want to order the numbers in decreasing order? So starting with the largest number and going down to the smallest number, and figuring out how many swaps we need to make to get to that ordering. Yeah, so, ooh, interesting. Let's see. This looks like, they're starting with 3. Why would 3, 4, 1, 2 be bigger than 4, 3, 2, 1? So maybe I understand this problem wrong, incorrectly. Largest possible value of num after any number of swaps. Hmm. So the explanation here is that we swap the digit 3 with the digit 1. This results in the number 3214. And we swap the digit 2 with the digit 4, and this results in the number 3412. Note that there may be other sequences of swaps, but it can be shown that 3412 is the largest possible number. Also, note that we may not swap the digit 4 with the digit 1 since they are of different parities. Oh yeah, this is why this is why I completely forgot about the parities issues. It can't be a simple case of ordering the digits in descending order. You need to consider parity. And for example, 2, the answer is 87655. We can only swap digits that have equal parity. I mean, what if we separated our array into odd and even numbers, and then we created, and then we what's it called, and then we sorted them in decreasing order, and then we kind of like stitched them together from biggest to smallest. Hard to explain, but I want to explore that idea. Probably not the, not probably, it's just an idea. So I'm going to go with it. So what if we did, first of all, we have an array of odd numbers. So that's 1 and 3, and then an array of even numbers, 2 and 4. And then we sorted them in decreasing order. So the first one becomes 3, 1, and then the second one becomes 4, 2. And, and, ooh, and depending on depending on what this sequence of numbers started in, whether it was an odd or even number, that we choose the array from which we will start our interstitching. So we'll start with this one and we'll do 3. We'll do, which one is bigger? No, we'll interstitching, right? So we'll do, okay, so depending on the parity of the index with which we want to fill, we'll either choose from the odd array or even array. So the index of this parity is odd, so we'll choose from the odd. The index of this is even, so we'll choose from even. And as we choose, we'll eliminate the values we have chosen from the arrays from the values we can choose from, and then we'll just continue doing that. So now that we have 3, 4, the next index is odd, so we'll choose 1, and that deletes that, and then the next index is even, so which is 2. So 3, 4, 1, 2, which is the answer we got. We could also check the idea with this. So the first thing is we'll look through this, and then we create an odd array containing all the odds, so 5, 7, 5, and then all the even numbers, 6, 8, 6, 9. So I think those are the only even numbers. And then we sort the arrays in, I should do that in place. We sort the arrays in descending order. 7, 5, 5, and then this becomes 8, 6. Yeah, and then we have this other array that we want to fill. So for the first index, we check if, by the way, we'll convert this into an array first, so that we can do the whole picking and sorting and all sorts. Right, so to get our answer, for the first index we check, is this an even number? It is an even number. So we go from the even and we choose 8 and we delete 8. For the second index, that's an odd number, so we choose 7 and we delete 7. For the third index, it's even, so we choose 6, delete 6. For the fourth index, both odd, so 87655, 87655. So I think we have like a roughly winning solution. I'm not going to think right now about optimizing this. I'm just going to try and code this out um, using JavaScript, in this case TypeScript. So first things first, how do we get an array of all the numbers in a number, of all the integers in a number? It's so weird saying numbers in a number. There's a tool for this I've become kind of familiar with, although let's see, I'll probably struggle to code it up. Um, so constant nums in num, and then let's see, while case is while num is greater than 0, something like that. I'll come back to that. Let's comment all of this out and push those to the top. And that one out as well. And so first thing is we kind of just, what do? We divide num by 10. What does that give us? Wait, chill. So this is 65875. To get this number, if we divide by 10, the remainder of that is, oh no, so we don't divide by 10, we just use mode 10. Mode 10. So what do we want to do? We want to push that into num is num. So presumably, the first time we do this, oh gosh. First time we do this, we have the last number. This is already going to be inverted. This means our outcome array will be inverted. So we have the last number, and then we should prepare for further divisions by saying num gets the value num divided by 10. I think so, yeah. So if I get the remainder when we divide by 10, which will be 5 actually divided by 10, so we get 6587. And then we keep doing that until, let's assume we just had 6. When we do 6 more 10, we have 6. When we do 6 divided by 10, we have a number that's less than 0. So I think this condition is cool. Let's see what we get. In num is num. There should be a utility to reverse in place, reverse an array in place. Yeah, array.put reverse. Yeah. Let me see. Does that return an array or does that actually do it in place? The reverse method reverses an array in place. Cool. And the way you colon it is to say the array.reverse. Cool. When we're done, we just want to do num is num reverse, just so that when we're going through and we're filling a new array, we don't have to worry about the issue that this has been reversed. Oops. Here's it. Oh, return. What do you want to return? We want to return number. Let's just start by returning 0. Cool. Now I want to check that. Ooh, nums. in num. I just want to check that, yeah, we're doing what we think we'll be doing at this step. Line 15. So let me put this. It's a daisy. Oops, 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 oops. Whoa. Why do we have such a huge... Whoa, this is unexpected. 227. Oh. Yeah, while num is greater than zero, not the best condition. Why not? Well, hmm, what am I trying to do here? So if we're six and we did number 10, yeah, well, it's gonna take a very long time before we get to zero. I guess the better condition will be to check while checking the first index. I don't know if that makes sense. Oh, come on, pop into my head. Um, what's a good end condition? This ends when, I guess, when this is less than one. No, greater than one. Ends when, so smallest number we're gonna have here is one, and one divided by zero by 10 will give us something less than one, and once we get something less than one, I think that's a good case for ending. So let's run this. For some reason, oh yeah. Oh, this is giving us so yeah, we get the first number, but this is giving us oh wow, this is giving us, what do you call it? Floating point numbers. We don't want floating point numbers. Dots, and I think there's a way to just remove every trailing, what do you call it? Trailing decimal math dot. I can't remember the name. Trailing. Just say trailing decimal numbers. Something in math. No, not this. This becomes no. This is not what we want. Doo-doo-doo-doo-doo. Math dot trunk. No. Just math dot trunk is what we want. Um, that's correct. So again, the actual API definition, TRUNC. Awesome. I think we, yeah, cool. Not cool. We do not get one. Awesome. That includes the reverse. So I think we're good to go in terms of the first preprocessing step, which is that there must be some way to do this as a math, but I'm not going to do that. For EL developers love immutable and functional type programming. Um, so the next thing we said was we're gonna split this num is nums in num into an odd array and an even array. So let's create those arrays. We don't need to, we can just do like a nums in num for each num. What we're going to check is um, if it's even or odd. If num else, oh, it has to be odd, right? And now let's see, what do we have? What do we have for? What do we have in odd and even? It looks like everything here is odd. That's wrong. So weird. If oh my, why am I doing? Why am I making such silly mistakes? If num mod 2 is 0, not if num divided by 2 is 0. Gosh. Alright, so looks like in terms of odd, we have the odds, and in terms of evens, we have the evens. And the last step from our original idea was to just go through the length, run through the length of the array, and then depending on whether uh, depending on whether the index, the number in that index of the original array is odd or even, we just want to, what are we doing? On shifting, we're taking from this end. Oh, something is wrong here. This is in increasing order. Well, we don't have to reverse. We don't have to reverse this, actually. It helps us not to reverse it. Push, pop, but if we do reverse it, yeah, it helps us not to reverse it. It's just a linear expense that we can do without. And then, cool. Depending on, let's just code it out. It's easier to put out and talk. So, let's less than plus. What do I want to do? If num I mod 2 is equal to 0, what do we want to do? We want to take from a result array. Want to push to the result array. I want to push, right? Yeah, I want to push. Num.pop or something like that. I think it's on shift. What do we do? I hope we're, so when we're unshifting, oh no, shift. Let's see. If it's not on shift, then it must be shift. Removes the first element from an array and returns a removed element. Exactly what we want. So num.shift basically. Not num, even.shift. Else odd.shift. I think this is roughly, what we had in mind. Converted to code. Let's see what that gives us. it's when it says there's an issue. Oh, norm in norms. Okay. Norms in norm. There we go. Type any is not assignable to type number. This is a TypeScript issue 35. Oh, we forgot to convert it into a number. Um, First of all, let's just see what we to do that. We'll have to join and then convert to a number. Right. So we're not even getting correct answers here. We have 3-1, but for some reason we have undefined, undefined. Norm is norms, and then in terms of odd, we're not getting anything in odd. Oh no, no, no. Odd is empty. Odd is empty because by the time we're done, it's empty. But we're not shifting from even. Why? Even a push on the push, we know that even gets created. Um, if norms I mod 2 is 0, yeah, oh gosh, so silly. There we go. 30 minutes on an easy question. Guys, this is why I need to practice. Yeah, so 3, 4, 1, 2. 3, 4, 1, 2. Okay, cool. Now all we have to do is response.join. Dot. Can you convert a string to number? How do you convert a string to number in JavaScript? I don't know. Parse int. But what does parse int? Just parse int? Haven't done this in forever. No, we don't want to use the number. Oh yeah, just parse int apparently. Cool. I think that should be it. I think we've, cleared up our original idea. Um, I'm shook. I did not expect that. The first number is odd. So yeah, it's to do with the way we're checking whether the number is even or odd. We're just checking if no it come on. The first number in this case in num. Oh yeah. I said it wasn't necessary to reverse it, but before doing this it's necessary to reverse it. We There we go. Yeah, there we go. Um yeah, let's see what issues we have with this solution. In terms of the runtime, it's purely linear. We're not doing anything special here. Let's try and submit. Moment of truth. Oh no. So 8575. Why is the odd array not starting from? Okay, there's something I'm not doing wrong. I'm doing completely wrong here. something subtle, but I can't see immediately. So I'm going to run. Actually, we have the output here, right? That doesn't really help. What I want to say is, where are we when we created our odd and even arrays? Let's run the fact and just run. Why is the odd array not sorted in the descending order of size? Because as far as I'm concerned, that's the only reason. Yeah, that's the only reason why mm, that would happen, and that's true. So I mean, if our 57856 57856, okay, okay. Well, seems like I do need to sort it for. Okay, so I forgot to sort it. The first example was already sorted. That was the reason why I forgot. But we want to sort it. We either want to sort it before or we want to sort our odd and evens. What I'm going to do is sort our odd and evens in reverse order. Using array.sort. There must be a way to say I want to sort in reverse order with array.sort. So let's look that up. Um, mm, 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 Arrow function, compare function. Okay, we can pass it a compare function. Um, so for the sort, we want a b take b greater than a. I think is what we want. Even sort ab also take b greater than a. Oh, best way to know if this works is to check, right? Let's look at sorts in the meantime. B minus a. What I can see here, I'm doing here is using subtractions. Since I'm able to number. Oh, I see. I actually have to do the sorts myself. Okay. Um, B greater than A. Okay. That did nothing. Just a sec. The quickest way to do this is simply to do this. So look at the sorting function some other time, but spent enough time on it. This is interesting. See, does it return an array or does it sort in place? It returns an array, so maybe that's why. Well, that's almost definitely why. Nothing happened before. Sort in place but returns an array because it is a constant. Ugh. So yes, this is why we need practice. Still nothing. Nope. Something. I wasn't even. I was not consoling.login after my sort. So why is it that? Uh, this is what I wanted to see. 755. Okay, well, let's submit. Let's see what other issues I have missed. We're 35 minutes in, and I'm still on question one, and it's an easy rated question. Oh, that's accepted. Cool. Let's go to question two. Doo-doo-doo-doo-doo. Oh, that's weird. Typically, when something gets accepted, the I guess that only happens in live contests. But typically, when something gets accepted, this should be highlighted as solved. Mm. Did I not start? Oh no, I didn't do this. So, yeah. Um, what do I do? I have already solved this. Oh, cool. Oh no, no. I don't know what is gonna happen. I don't. It's probably yeah. The rank I get is not gonna be accurate because probably thinks I solved this question instantaneously, right? So whatever. So this is the second question. Let's move over here. It's a medium difficulty question. We want to minimize the results by adding parentheses to expression. What does that mean? Oh, like a math thingy. Okay. You're given a zero index string expression of the form num1 plus num2, where num1 and num2 represent positive integers. Zero indexed string expression of this form, for instance. Okay, alright. Add a pair of parentheses to expression such that after the addition of parentheses, expression is a valid mathematical expression and evaluates to the smallest possible value. Okay, the left parenthesis must. Okay, so I'm going to stop here because I've read all this and nothing is coming to mind. So I just want to look at the examples. 247. And I get that we want to add parentheses. We want to minimize. This seems like a criterion optimization problem. Typically, you'd solve this using some sort of linear programming. So it's very likely I'm going to struggle with this question because I simply haven't practiced that many linear programming questions. But we'll see. We'll have to see. The left parenthesis must be added to the left of the addition, and the right parenthesis must be added to the right of the addition. Okay. Okay. What are we trying to minimize? We're trying to minimize. It's either we're trying to minimize the factor by which we're multiplying. Hmm. This is interesting. This is a, this is not intuitive to figure out what we're minimizing. Like look at this one. We minimize the factor by which we're using to multiply 1, but we also allow another factor for multiplication. In what world is 4 times 5 greater than, yeah, it is 37. We're trying to minimize the whole thing, but we need to do sub-minimizations. On the right while we're trying to minimize, on the left while we're trying to minimize. And we can't even divide it into right and left by the addition. We have to divide it into right and left by the multiplication. So there are three things we're trying to minimize, I think. The summation, the right multiplicand, and the left multiplicand. Okay. The left parenthesis must be added. That's a rule. That's a rule. Return after adding a pair of parentheses such that the expression evaluates to the smallest possible value. If there are multiple answers that yield the same result, return any of them. Okay. The input has been generated such that the original value of expression and the value of expression after adding any pair of parentheses that meets the requirement fits within it the signed 32-bit integer. Awesome. So I don't have to worry about I don't have to worry about max ints, but do I have to worry about small mean ints? That's a question. Well, that would fit, right? I do not have an immediate solution to this, except a brute force try all possible parentheses, save all those answers, and return the parenthesis configuration that that gave the minimal summation. And even doing that, how would you do that, right? How would you do that? You have to fix, so you have to loop through all the think of this two as arrays again. You have to loop through all the possible positions that you can put a parenthesis in within this array, and then for every of those you have to loop through every other possible position in the other array, which is it's O of n over 2. No, this is assuming that it's, well, you could say it's O of n over 2 squared, which is O of n squared, in the length of n being what do you call it? The number of numbers in any of these, preferably the one with the maximum, with the higher number of numbers. That's brute force. And you have to evaluate the expression you derive. It's kind of like create all possible expressions you can create from these numbers, and then evaluate all of them, and then return the one with the smallest results. I mean, it's what I have, so it's what I'm going to go with. It's probably going to time out. It's an O of n squared solution, but is there a way to get an O of n solution from this? I don't know. Like I said, I don't have a lot of experience, practice with linear programming. I don't even know if this is a linear programming problem. You definitely do not want to. I mean, one optimization we can use is not evaluating expressions we've seen before. I don't know how possible that is, but yeah, before we push before we push anything into the area of expressions to evaluate, we could check if we've seen it before, but I'm not even going to bother with that to start with. I'm just going to try and see if this accepts an O of n squared solution. So again, we want to create two arrays. We want to create two arrays. In this case, we'll end up with 2, 4, 7. Do we even want to create two arrays? We just want the length of these arrays, don't we? I don't think we even need two arrays, but conceptually we think about it as two arrays. And then maybe we do want to create two arrays. No, we don't. Anyway, so we end up with these two arrays, and then the next thing we want to do is okay. So think of this as for every we want to loop through. We want to create an array that will contain all our expressions, and then we want to look through the first one. You can just do that by saying mm, how do we say we want to place a parenthesis here? Not here. Not here. There's no point placing a parenthesis here. We can't place a parenthesis after. So when we say we want to place a parenthesis at index I, we mean we're placing it in front. Okay. So for every I in A, just say that's that and that's that. Funny enough, this is valid JavaScript, which is weird. Like weird, right? For every I in A, for every K in B, what do we want to do? We want to do we're placing two parentheses. Oh yeah, I want to place a parenthesis at I and K, I think. Okay, so what does that mean? That means we're going to choose 2. So we're going to choose from I and K. So starting off, we're going to do 2, 2, 3, and then 2, 8, and then 4, 3. No, I'm already tired of doing new lines, so let's separate them like this. 4, 3, 4, 8, and so on and so forth, right? And we're going to push all of those to here. 2, 3, 2, 8, 4, 3, 4, 8. Do this. 3 to 8, let's just be consistent with what we started with. 4, 3, 4, 8, and so on and so forth. Okay, thank you, Barclays. And then next, we want to evaluate all these expressions. So we have, this is interesting because we're going to have to create something that Are we? Are we gonna have basically an interpreter, right? For these expressions, we have two options. We could push the expressions in here fully formed and then run the interpreter on them. What are we actually returning? We're returning the actual expression. So, I mean, it makes sense to push the expressions themselves. So let's see if there's an easy way to do that here. The template is 247 plus 38, right? So we're basically doing some sort of, this is a string dot, that's an expression that inserts into I, in front of I, open the open brace, and then x dot insert. Oh, I didn't even think of the other one. So we can't do anything here. So behind I or behind K, what we're doing with K, close brace. That's the expression. I don't want to have to build an interpreter to interpret the expression and then evaluate it. I just want to see if I can evaluate as I create the expression. So something like, I mean, we have the options for doing this. Store the expression with its response, or just store an equivalent array with all the responses, and so on and so forth. I am struggling because, why am I struggling? I'm struggling because I just don't, this expression interpreter thing is messing my head. But okay, I think the last thing I want to know is, can I evaluate these expressions mathematically without stress? At this point, I am assuming that I have this broken up into some sort of array that looks like this: 247 plus 3 and 8. Now, maybe it's easier to actually create the expression and then evaluate the expression, because I don't want to be going in and parsing, joining numbers and this kind of stuff. So to evaluate the first expression, 2, 3, we have what this tells us: insert that at 0, and then that means we have 247 plus, insert the second one at 0, 8. That's what we have. How do I evaluate this? How do I evaluate this as a mathematical expression? It's not valid JavaScript. Can I make a valid JavaScript and tell JavaScript to evaluate it for me? It's not valid JavaScript without. See, I just added that. That would make it valid JavaScript. Oh, almost. I added one before every, and added one after every. So times 1 times whatever times, maybe whatever 1 times still the same problem. Anyway, oh man, I'm so stuck because I'm just falling up short in terms of in terms of the sub problem of converting this into a evaluating this as a math expression. Guess I'm just gonna take a breather and hope something comes to mind. Let's just take like a 30-second breather. Mm, mhm, mhm, mhm. What happens when I do this? That looks interesting. I wonder what's going on with Chrome. What happens if I do this in JavaScript? Yeah, it's only valid if I do that. I have two options. Either find something in JavaScript that runs strings and evaluates them for me, or create an interpreter. So let's search. That's one possible thing to do. Oh wow, internet is really slow. Okay, while that loads, let's think. Okay, so whatever's within the square braces, we want to get the substring of that, split that into two further substrings, convert those into numbers, and run an addition on them. Whatever's on the left hand side of the opening brace, we want to convert into a number, multiply that by the response from the first previous step, and then want to do the same thing for the other one. I mean, I guess it's not too hard to hard code that as an expression evaluator. First of all, I want to know, oh yes, there is something called an eval. It's just to have to save myself the time of coding that if a string represents an expression, eval evaluates the expression. Awesome. I can wisely add multiplication operands to this expression and use the built-in eval thingy. Hey, so I don't have to waste my time coding that. Um, and the problem I now have to solve is how to add these multiplicative operands when necessary. The pattern here is if there is nothing, and there is only ever nothing if we're starting with the zero in x. Yeah, then don't add the multiplicative thing operand. If we're not starting with the zero index, add the multiplicative operand. So we're going to add a space, so that looks like that. Same thing happens here. If we're starting with the first one, is the opposite. Always add the multiplication. Nope. I mean, we want to add it if there's something. Actually, no, why am I stressing myself with all this? Just check what happens if we have an expression like that, like this. Does JavaScript evaluate this correctly? Yeah, it doesn't. It's not JavaScript. But I didn't check what happens if it's a string. Mm, what for strings? Okay, so I need to stress myself. Ooh, let's look at the pattern. Let's actually draw out the pattern. So that it's more clear what we're doing. So the first thing is 0, 0, or in other words, 2, 3. So what do we have? Let's expand the pattern about four, 5 levels in. Right, move that over away. And first of all, this is what we get with the first one. Then the second one, 2, 8. This is what we get. Third one, we move on to 4. That's what we get. And then that, and then what happens when we run out? Actually, I want to see this to the end. What happens when we run out? Yeah. Well, we run out. There are only 6 possible. Okay, so what do we want to do? We want to not add anything here if it's the first index. But if it's the second index, we want to add that star. If it's not the first index, we want to add that star. Same thing here. We want to start here. We don't want to start here. We want to start here. We don't want to start here. Let's start here. Okay, so what's the correlation between the indices on the right hand side? If it is, if it's the last index, we don't want to star. It's kind of the inverse, right? If it's the first index, we want to star. If it's the last index on the right hand side, we don't want to star. If it's not the first index on the left hand side, we want to star. If it's not the first index, if it's not the first If it's not the first index on the left-hand side, we want to star. If it's not the first index, I don't think that exists. I want to put this in actual code language. Just ignoring the left-hand side. On the right-hand side, if it is not the last index, we want a brace star. If it is the last index, we just want a brace. That I can code. That's for the right-hand side. Whereas on the left-hand side, if it's the first index, we just want a brace. If it's not the first index, we want a star brace. I think I have all the pieces I need to solve this, and I have less than 30 minutes left for this competition. So yeah, really slow, but that's the point of practicing. Where to begin? 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 We don't need this array. We don't. We can do insert into strings. Okay, we do. We don't. We need to split the string into half. We don't need this array. I don't think we need this arrays either. But we do need to split the strings into half. So let's just comment out all of that. We'll use the convention left expression dot split. Is it split or is it splice? I'm always confused. Yeah, let's look at the doc. Split, 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 split. Something about the okay, that was a really good search. As I was saying, sometimes I find it easier to find stuff I want in the MDN documentation by searching Chrome directly. We have 20 minutes, just about 20 minutes to code this up. Let's see if we can do that. Divide a string into an ordered list of substrings, put the strings into an array and return to an array. Division is done by So splitting by, okay, cool. I think it's split that we want. And then, oops, let's close that. Ugh, I'm going to split 2 times. It's fine. Okay, cool. So now we have our 2 arrays, and then we just want to loop through, right, like we did here. We use the for let loop. For let I gets value 0, kill. All right, I'm back. So where to stop? Yeah. So for let I gets value 0, I less than left dot length. Can we get the length of the string by accessing the length property, or do we need to use the method? Gosh, so many things. That I don't have at the tip of my fingers. Okay, so yeah, it's not Java, it's JavaScript, and it seems that it has the property. You don't need a method. Okay, cool. And we'll keep going for let k gets value 0, k less than right dot length a plus plus. What do we want to do? We're going to be pushing expressions to evaluate to evals. If I, that's good. Let's factor in those cases, those edge cases that I talked about earlier. So okay. I hope this is immutable. I hope the operators I'm about to perform on this string are immutable. Otherwise, this is going to be a bit tricky because I want to add the opening brace and then go on to add the closing brace depending on some conditions, and I do not want to be mutating my expression string. But yeah, strings are immutable. That's a core fundamental thing in JavaScript. So constant eval expression. Oh, it's an empty string. Sorry. Okay, so now we said that if it's the first If it's the first index on the left, then we want to add just this. Whereas if it's the last on the right, we want to add just this. Otherwise, for I, we want to add, what do you call it? We want to add a star with open brace. And if it's not the last on the right, we want to add an open brace star. Question now, last thing now is to do the actual adding and so on and so forth. We have about 20 minutes, just roughly about 20 minutes till the contest time is over. I'm really hoping I can get through this in time because that'll be like a huge positive for me. It's like I know what I want to say, but I'm just so not good at this this language. Why? Yeah. So what I want to do here is eval gets the value expression dot. No, I think it's easier to start with the fact that this is expression. Then just eval gets the value eval dot. How do you insert something into an index? String dot insert, string dot split. I don't think string dot insert exists in JavaScript, but we'll see. I think we have to splice and then join. Yeah, slice rather. I'm going to look at the slice documentation itself. String dot slice. I wish they put a link here. Slice, not splice. I mean, this is where a lot of my time goes to anyway, looking up documentation. That's something I can improve. What does slice do? Extracts a section of a string and returns it as a new string without modifying the original string. Nope, we don't want slice. We don't want replace per se, but we want something close. Why isn't this thing coming to my head? Mm, mm, mm. That's so weird. Mhm. Hmm. These are all the string methods we have. There's nothing else. What I want to do, I want to, yeah, I just want to insert. I mean, I can convert it to an array and insert it. That's a lot of unnecessary stuff, in my opinion. I mean, at least I know for the first one, the concat does work. Seems the ideal way to do this is to actually just break up the string and then put it back together um, using substring. Well, guess I'll do that. Where's substring? Okay, that's deprecated. That's also deprecated. Oh, this is it, substring. Yeah, I think substring works. Let's see. Question now is what's inclusive and what's not inclusive. It's not inclusive of the 0, 1, 2, 3. It's not inclusive of the final one, but you can just let it go towards the end. We'll see. We'll see how we get around that. It's inclusive of the first one. I'm not going. Visualizing this is a bit difficult. Um, let's look at something like this. We want to take the substring starting from I. Okay. Starting from 0 ending at I. We want to concat with. Here let's use that syntax. Let's just use the syntax. And then we want to concat with the substring starting from I. That's what I want to do there. Otherwise, anything we're changing here, it's repetition that we could probably eliminate. Is that and subtly different, but let's see. With K, yeah, 0 to K, I think. And then we want to add that if K is equals to K dot length. If it's the first one, this is unnecessary. If it's the last one, then this is unnecessary. Okay, and the last thing is this here for the extra space. Only about 10 minutes left for this question. Capital K, small k. If it's not the last one, get up until K, add on that, and then get from K onwards. Okay, now we have a problem. Each time we add anything on the left hand side, the index that we're accessing on the right hand side increases. Oh gosh. I didn't think about this earlier. Kind of just do this all at once. I think it's easier to do this all at once. It's harder to do this all at once. I think I can do this all at once. Let's see. Um, let's see here. Concat can take a function. Okay, even if we can't take a function, I hope we can take an expression. Okay, I think I know why this is difficult for me. Um, I need to solve the problem of adding new characters to the string while trying to access the same indices. I need to update the indices. Okay, if I is 0, then we add one character to a value substring from I. Meaning I now has one character. Else we add two characters. A substring. Um, This is a legitimate problem for me. I will have to. If it's something that comes up often in problems, I can imagine it does. Like you're trying to index into a string while updating the string. How do you maintain the correct indices? Mm, First thing is if we're drawing from an immutable string, we wouldn't need to worry, but we are updating our string. By the way, this should be a let. We are updating our string each time. We're actively updating our string, and this is the problem of mutability, right? Ugh. If hmm, wish I could do it all at once though, like mm, 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 mm. So okay, well I guess I could do this. Let's assume that let's assume that let's assume that this is why I used the other expression. Let's assume that it's always the first. Let's skip concatenating the second. So this is why it's always the last. Then let's handle the special cases after. Funny enough, the replace just makes this perfect. Yeah, perfect. Only 2 minutes left. Cool. Just want the satisfaction of knowing that we were able to create an array of evaluations to evaluate. Let's see what issues we came up with. It's going to tell us we need to return something. Not returning a string. Let's return an empty string. Oh no, we're using the word eval. Let's to eval keyword. We can't use the keyword. Come on. Now I have to replace. Can I do a control F? No, I can't do a control replace. Can I not? Eval. eval. Okay. Well, it's already past time. Already it's already an hour and a half spent on this, which is past the physical contest time. So I couldn't even get past the second problem, which is ugh, really bad. um, let's print out eval, but I do want to see have the satisfaction of seeing that. But oh no, I can't print out eval. What I'm trying to print out here is evals. Is that we were able to generate an array of expressions to evaluate. Length does not exist on type number. And what line was that? Line 19. Oh no. Um, so 1, 2, 3, minus 1. Oh no. After all that coding, we have an empty array. Of course, we have an empty array because we're not pushing anything to our array. So, it's terrible. It's wrong. It's completely wrong. But this is something I have found difficult. I'm going to find it interesting. Walking through this problem fully, but for now, this is where I'm going to stop. I think I'll continue this tomorrow. Yeah, given that I wasn't able to finish the contest today, I'll just continue this contest tomorrow. But I don't want to spend too much time in one sitting. Yeah, so see you guys tomorrow. This was kind of fun for me, kind of mostly sad that, I couldn't finish this. But yeah, I'm hoping that with practice, I'll get much better.